Hey everyone, this is Daniel for Rock the JVM, and this is a tutorial on open authorization, or OAuth, in Scala with Http4s. This is going to be a comprehensive tutorial, so if you want to make the most value out of this video, I recommend that you write code with me. In order to do that, you will need some basics of Http4s and cat's effect, both of which you can find on the Rock the JVM channel and described and taught in detail in my cat's effect course and in my giant Typelevel rite of passage course. I'm going to link both in the description as well. If you prefer to read instead of watch, I have a written version at the blog, as always, which you can check out. I'm going to link that as well. I'm going to recommend that you keep the blog version open because the blog post also contains some library dependencies that you will need to set up your project if you choose to write code with me. So without further ado, I'm going to switch back to my development environment where I have a plain object that we're going to develop from scratch. Now, here's how this OAuth business is going to work. OAuth is an open protocol, and it's implemented by large companies like Google and Microsoft and GitHub and so on and so forth. We're going to use GitHub as the open authorization provider for our toy application. So here's how the OAuth quote-unquote algorithm works. User, that is you, tries to log into my application. For example, click a link. Like login with GitHub. Number 2, this redirects the user to the GitHub authorization page. So this will redirect the user to the provider, to the provider's authorization page. And this will show a small pop-up saying, do you want to authorize this application to use your data on GitHub? Number 3, after you grant the permissions for that particular application, you will redirect it, so user is redirected to a callback page on the small app. And the small app is the stuff that we're writing right now with a code. Number 4, with that code, the server will have to validate that code against the authorization provider. So the number 4, that is in the backend, the server gets data from the auth provider with that code. Number 5, still before the user sees anything like you are logged in on the small app, so on GitHub, the GitHub server, so auth server, responds with an auth token and some data. Number 6, server, or my small app, shows something to the user depending on the token and the data. So for example, if the auth token says GitHub authentication successful, then my small app will say, hey, you have just successfully logged in with GitHub. Welcome back, Daniel. So we're going to implement all of these 6 steps on our application. First of all, I will want you to navigate to your GitHub account. I'm pretty sure that given a developer, you probably have a GitHub account. So go to your profile and go to settings. So right here where it says settings, and in your settings, navigate all the way down to your developer settings. So click on developer settings and click on OAuth apps, the second thing in the list. Now, you need to register a new application if you want to create an app that authorizes GitHub. So I'm going to register a new application. I'm going to call this OAuth test. You'll need to provide a homepage URL, and that is going to be http://localhost 8080. This is going to be our development server /home, for instance. Application description, let's say testing OAuth with Scala. This is not really that important. An authorization callback URL, this is super important. I'm going to copy that, and I'm going to provide a path on my server. I'm going to call this callback. So I'm going to provide this route on my server so that GitHub can redirect the users back to me. So after you've filled in this entire form, click on Register Application. The client ID is going to be very important. So this thing called the client ID, copy that, and go back to your application, and I'm going to create a source main resources folder. So I'm going to create a directory under source main, call this resources. And under resources, I'm going to create a little file called appconfig.json. And this will have a small JSON called key, and I'm going to paste my little string, and I'm going to have a secret, which will be generated from GitHub. So the secret will be a string. And I'm going to click on this button, generate a new client secret. This is very important. I'm going to click this button. I'm going to supply my little password here. And I'm going to copy this little secret. It's in plain text, but I'm going to delete the application at the end of the video, so there's no security problem here. So I'm going to copy this, and I'm going to bring this back to my little JSON configuration. Now in Scala, I will want to parse this file, and I will use a library called Series, or Cyrus, depending on, I don't really know the pronunciation of that. So I'm going to navigate back to my little OAuth demo, and I'm going to create a case class. I'm going to call this app_config with a key as a string and secret as a secret of type string. So I'm going to import series.secret. I'm going to simply pronounce this library as series. So series star. The reason why I'm storing the secret not as a string but as a secret string is because this secret data type hashes the string. So it's impossible to read this from a third party if I accidentally leak it out somewhere. So I'm going to create a given. Let's call this app decoder, which is a source decoder. So decoder that I'm going to import from source. So I'm going to have import IO source. I'm also going to import series source. So this is going to be a decoder from IO source, decoder of type app_config. And I'm going to create a manual decoder. So decoder instance, which takes a function that takes a value called a cursor, and this parses JSONs manually. So I can say for comprehension, I'm going to say key as hget of type string with the identifier key, which is the key in the JSON, and then the secret as h.get of type string, and the key in the JSON is called secret. I am going to yield app_config with a key and secret wrapping that secret. All right, so I'm going to run a for comprehension here, and this is going to give me back the decoder. So this is going to be the app decoder, and I'm also going to create another given. Let's call this app_config decoder. And I'm going to say source config decoder with the type name app_config. And this string is very important. It needs to match the name of the class. Now, because of Scala 3, I need to provide the type for this app_config decoder, and that is going to be a config decoder of type string and app_config. So this takes a string and returns an app_config when parsed. Now, this app_config will be necessary for us to automatically parse that little JSON. So here in my auth demo, I'm going to have my val, let's call this app_config. And this is going to be, and I'm going to use a construct called file, and this is a utility function from series. And file takes as argument a path, which is a Java path, to the file that we want to parse as this desired type, app_config. So I'm going to have paths in Java, paths.get at source main resources app_config.json. Now, this app_config is a config value effect string, and I need to convert that to my desired type called app_config, so I'm going to decorate that as app_config. Now, in order for this thing to work, the givens need to be present in the companion object of app_config, so I'm going to write all of these in an object called app_config. Okay, so we have the case class app_config, and these two givens are in the companion object. You can pause the video to write these yourself in your own project. Now, I'm going to collapse the code because I want to focus on the rest of the app. Now, to implement the first step, the user tries to log into my application, they need to click a link on my homepage. So I will create a bunch of routes on my Http4s server. Obviously, I don't have an Http4s server, so I need to define it. So let me go create my val, let's call this routes. And this is going to be HTTP routes of type IO. So HTTP routes needs to be imported, and I'm going to import org HTTP4s star. I'm going to also import org HTTP4s server star, and also Http4s implicits star. So these are some of the standard packages that I use for Http4s applications. Okay, now I'm going to create an HTTP routes of type IO, and the IO data type belongs to cats effect. So let me import cats effect as well. So import cats effect everything. So HTTP routes of IO, and then we have a pattern match on all the routes that we want to support. Now, in order to gain access to the Http4s DSL to pattern match routes nicely, I'm going to have a val DSL as Http4s DSL of type IO. So I need to create one of those, and I need to import it as necessary. So that's going to be Http4s DSL. I'm going to import that, and I'm going to import DSL everything. So I'm going to pattern match against the following routes. I'm going to have a get at root / and I'm going to create a small page like index or home. And I'm going to return a simple static file. So I'm going to do return a simple HTML. And in case we get a get at root / callback, and I'm going to supply a query parameter shortly. So this is to do add GitHub query parameter. I'm going to add another to do, validate the code, and return success or failure of authentication. So I'm going to comment the callback for now, and I'm going to focus on returning a very simple HTML. So I'm going to return what is called a static file. So I'm going to import static file from Http4s. We already have that in scope. And I'm going to say from string, and that's going to be the path of my index HTML. So I'm going to say source main resources, and I'm going to have, let's say, an HTML folder, index.html. So static file from string at this particular path. Now, from string takes two arguments, URL and the request that was just issued to the server. So I'm going to have my request at this entire pattern, and I'm going to pass my request as a sum, so sum req. And this is going to be my file that I'm going to serve. Now the problem is that this construct returns a monad transformers option t f response f, which is essentially a wrapper over an IO option something. So I am going to say static file from string get or else f. I'm going to return not found, and that's going to be the HTTP response if this static file doesn't exist. All right, so right now I'm going to create the index.html. I'm going to spin up my server, and we're going to have our step one ready. So user tries to log into the application. So under source main resources, I'm going to create a new directory. I'm going to call this HTML, and under HTML, I'm going to create a new HTML file, index.html. And thankfully, we have a little placeholder here. I'm going to have a link. So let me add a little p tag. So p, and under p, I'm going to say click here. So href. I'm going to have a to do here. Here to log in with GitHub. And that's going to be it. So ahref, let's say github.com. So https://github.com. And this will redirect us back to GitHub. We're going to fill in this link shortly. So I'm going to save this, and we're going to get back to the application to spin up the actual server. Okay, so right now we have these routes which just serve a static file when we try to access /home. Let's spin up the server. So I am going to make this OAuth demo extend ioapp.simple. So this is going to be a standalone cats effect application. And in my override run, so I'm going to override the run method, I'm going to run a for comprehension. The first thing that I'm going to do is load the app config. So I'm going to say config as appconfig.load, and that's going to load with an effect type IO. and then I'm going to yield unit because I don't care about the return value of this entire program. So appconfig.load.io returns an IO of type appconfig. Now, with this appconfig as an IO, then I can spin up my server. So I'm going to say server as, I'm going to use the Ember server in Http4s. So I'm going to use Ember server builder. I need to import that. And I'm going to say Ember server builder.default of type IO. And then I'm going to supply the host and port. So I'm going to say with host, and I'm going to use an S interpolator, and that's going to be IPv4. That's going to be localhost, or let's say 0000. And then with port, and I'm going to have a port interpolator at 8080. And then I'm going to say with HTTP app. And with the HTTP app, I need to supply my routes. So I'm going to say routes or not found. And then I'm going to have build. And this is going to be an IO of type server. Now, these interpolators come from a library called Comcast. So I'm going to import Comcast, IP4s, everything, which will import the interpolators that I'm using here in the run method. Now, because this whole structure is a resource, I'm going to call the use method on it. And with the server that I hold inside, I'm going to say IO with print line rock the JVM so that I can see something in my console, and then IO never so that the application never finishes. So config and server, and then I'm going to yield unit. Obviously, we're not using the config yet because the config will be necessary in the implementation of the routes. So we're going to refactor the code as necessary. Right now, I'm just going to have the very simple server that will serve my index file. So let me go run this little application just to see if my code compiles and serves my very simple index.html. All right. So let's test it out in a browser. So I have a browser window here. I'm going to navigate localhost 8080/home. And this should serve my basic index.html. So it says, click here to log in with GitHub. And if I click on this link, I'm going to navigate back to my basic page on github.com. Okay, so our basic server works nicely. Let me stop the application and let's switch back to the code. Now, step number 2, we need to redirect the user to the provider's authorization page. Now, where does that provider authorization page live? I'm going to navigate back to my index.html. Right now, I'm navigating to github.com. This is the place where we are going to change the link. And the link can be fetched from the GitHub documentation. I have it handy with me. So it's github.com/login/OAuth/authorize. So this is the path. And then you need to supply some query parameters. First of all, you need to supply the scope. That is the kind of data that GitHub will give back to you when it redirects to your callback page. So you need to provide a scope, and scope is equal to, and there are a bunch of things that GitHub can surface for you. I'm just interested in user email, and that's formatted as user:\email. This is custom to every OAuth provider, so user email. And client ID is equal to, and the client ID must be equal to that exact client ID, that key that we stored in the application config.json. So I'm going to copy this little token, go back to my index.html, and I'm going to paste that client ID. So this is the client ID. So this is the place where we will be redirected. Okay, let me switch back to my demonstration. So we're done with step number 1 and step number 2. User is directed to a callback page on the small app with a code. That is after the user grants the authorization from GitHub. Now we need to add that callback route in our HTTP logic. So we need to add that little pattern match case here for get root/callback. Add GitHub query parameter. The query parameter that GitHub will add to our link is localhost 8080, which is /callback, the URL that we supplied in the GitHub settings, and then GitHub will attach a query parameter, which is code is equal to, and that value needs to be fetched by us. So I am going to create a little object. So I'm going to say object. Let's call this GitHub token query param matcher. And we need to create a matcher for every query parameter if you looked at the Http4s tutorial here on Rock the JVM. So this extends query param decoder matcher of type string. And the name of that query parameter is called code. Now, query param decoder matcher, I think, needs to be imported. So I'm going to import that. And this GitHub token query param matcher needs to be placed here in the pattern match. So I'm going to say colon question mark, which is the symbol for start parsing query parameters. So I'm going to paste this here, GitHub token query param matcher, and I'm going to have my code that Http4s will parse for me. So I'm extracting the code from the path. Then I will need to validate that code and return success of failure or failure of authentication. So I'm going to run some little method. Let's say get OAuth result with that code. And I'm going to create that little method for me. And then I'm going to say maybe handle some errors and things like that. But first, let me define my little method get OAuth result. Okay, so I'm going to create a function get OAuth result with a string. Now, remember, when the user is redirected to the callback, the server will contact GitHub again. So I will need that key and that secret from the app config. So I'm going to have my config as my app config here as argument. Now, because the get OAuth result requires a config, I need to pass it here. So I'm going to have my config. But my config is not present because my routes is just a value. So I'm going to turn that into a def, and it will take my config as app config as argument. Okay, this will return an IO string, and I'm going to keep it a question mark for now. And in my Ember server builder, where I build the routes, I'm going to say routes with config or not found. Okay, so I'm passing this as argument. Cool. Now, this get OAuth result, I'm going to map with an OK. So I'm going to say OK with underscore. So whatever the result is, I'm going to return an OK with that result. I think I need a flat map, though, because the OK constructor returns an effect. So I'm going to say flat map instead. So get OAuth result flat map, and I'm going to return an OK. Cool. So the only thing that we need to implement right now is this question mark. So the user is redirected to the callback page on the small app with a code. We have that, so we're in step number 4. In the backend, we need to get the data from the auth provider. So we need to contact GitHub with that particular code. So this is going to be the code. And with the config, so that we identify ourselves as the application who requested that code. Now, this interaction between our app and GitHub, steps number 4 and 5, is also a multi-step process. So first, we need to contact GitHub URL. So that is going to be the authorization URL on GitHub. So we need to be a client. So that's an HTTP client here on Http4s. So our Http4s needs to be a client to GitHub. Number 2, GitHub gives us back a string, and this is going to be a JSON string. And step number 3, we need to decode that string. Okay, now let's take these little steps and try to organize them roughly into their own methods. So I'm going to create a method, let's say fetch JSON string with a code and the config. This is going to be an app config. This is going to return an IO string. And we will need to contact the following URL. We need to contact github.com, login, OAuth, and access underscore token. Now, this is a post request, and we need to provide the URL form. So we need a URL form as into a post request. And we need to provide the following items. We need to provide the code. We need to provide the client underscore ID, which is the key from our config. And we need the client secret, which we can also fetch from the config. So I'm going to create my form. So this is going to be a URL form from org http4s, where I'm going to supply a bunch of associations. Like client underscore ID is going to be my config.key. Then we need the client secret. So client secret as config secret, but this is hashed, so we need to extract its value. And then we need the code, which is the code. So this is our URL form that we need to add as a payload into a post request. Okay, so let's go do that. So I'm going to have my val request as a request of type IO. So this is a constructor that issues back an IO request. We need method.post. Then we need the URL. So this is going to be URI quote. And we're going to have this little thing. So https://github.com login OAuth access token. Then I need my headers. So I'm going to have headers as headers with accept, media type, application, JSON, so that GitHub knows to give me back a JSON response. And then I need to supply my payload, so with entity form. Now I need to import the accept type from org http4s headers. So I have my form, I have my request, and I need to actually shoot that request to GitHub. In order for me to do that, I need to instantiate a client. So I'm going to say ember client builder default of type IO, so like the server, then build, and then use, because this expression returns a resource. Given the client, I'm going to say client expect on this request, and I'm going to expect a string. Now, what this request returns back to us is a JSON string that gives us back an access token, which is a string. Then we have a token type, which is also a string, and then the scope, which is also a string. So these essentially limit the capabilities of this particular access token. So notice that no actual data from the user is actually being surfaced. You need to issue another request to GitHub to fetch the user's data based on this access token. All right, so this is yet the first step. I'm going to parse this response into these three different fields. So I am going to go back at the bottom of the application, and I'm going to create a case class. So case class, let's call this GitHub token response with an access token, and that is a string. The token type is going to be a string, and the scope is going to be a string. Now, this also needs to be parsed from JSON, so I'm going to have a given, let's call this decoder, and that is a decoder of type GitHub response. And I'm going to build one manually, decoder instance, where we have the cursor, and I'm going to use the same pattern as we did for app config. So I'm going to have a for comprehension, and I'm going to have my access token as get string with the key access underscore token. These values are taken from the GitHub documentation. Token type get string token underscore type. So make sure you type these correctly because the names of the fields are important. And then the scope as get string scope. And then I'm going to yield GitHub token response with access token, token type, and scope. That is essentially it. Okay, so after I've done that, the case class, the given decoder needs to be put into the companion object. So object GitHub token response. So I'm going to collapse this. I'm going to collapse app config. Right, now after I've gotten that, I need to decode this automatically from JSON. So from this expression, I'm going to call map, and I'm going to return a string, which is a JSON string, so JSON string. Then I'm going to call a function from Circe called decode. And this decode function needs to be imported from a package called IOCirce parser. So I'm going to import that from IOCirce parser. And that will give us access to the decode function. Notice that it's blue now. And we need to take a type argument here. It's GitHub token response on that JSON string. And the decode function returns an either, where the left-hand side is an error, and on the right-hand side, the desired value is our desired type. And this is going to be our GitHub token response. And then I'm going to map that again. So I'm going to say map. And in case we get a left with an error, I'm going to return some absent string. So probably my fetch JSON string needs to be an IO option string. So left E, I'm going to return none. And in case we get a right with a GitHub token response, then I'm going to return just the string, which is the token. So I'm going to return a sum with GTR dot, and we're going to have the access token. So this interaction accesses this github.com login OAuth access token, and I'm going to return an IO option with an access token. So the GitHub gives us back a JSON string. We decoded that string, and we have the token in place. So we have the access token. So these were 1, 2, 3 from the fetch JSON string. Now, after that, after we get the token, we now need to fetch the user's information. So I'm going to create yet another method. Let's call this fetch user info. And fetch user info is going to get an access token, or simply a token, as a string. And this will return an IO string, which will be the user's email that has just been authenticated. Again, we are going to have a 3-step process. We're going to pass some request that we're going to send to GitHub, and then we're going to call this Ember client builder default build use, and we're going to send that request to GitHub at a different URL, and we're going to return the string according to the user that has just been authorized. So let me build my request as request of type IO, and I'm going to have a method get in this case. Then I'm going to supply the URI. So this is going to be Http4s, and this is API github.com/user/emails. This is from the GitHub documentation. And I'm going to supply some headers. So I'm going to have headers as headers plural, and I can supply multiple headers. I'm going to supply the accept header to accept JSON. So media type, application JSON, as well as the authorization in the form of an auth bearer token. So I'm going to have authorization with credentials.token, and we need to supply the bearer scheme. So auth scheme.bearer, and then the value here is the actual token that we have as argument. So this is the request. Now, we need to shoot that request to GitHub. So I'm going to get Ember client builder default.io build use and so on and so forth, the same construct here. And then I'm going to map. And I think I need to import authorization from the headers package. And you know what? I'm actually going to cut out the map, and I'm going to simply return the JSON string so that you can see the kind of shape that GitHub returns to us. And in my main function, get OAuth result, I'm going to run a for comprehension. So I'm going to try to get the token as a maybe token and the method is called fetch JSON string. So fetch JSON string with code and config. And then if this maybe token is an option containing a value, then I'm going to call fetch user info. Otherwise, I'm going to display an error. So I'm going to say, let's call this result in maybe token match. And in case we get a sum token, I'm going to call that method. So fetch user info with that token. In case we get a none, I'm going to return a plain string like authentication failed, and I'm going to wrap that in an IO. So I'm going to say IO authentication failed and yield result. So this is my toy implementation for get OAuth result. And just to recap, my routes are over here. So if I click on the link in index.html, I'm going to get back on GitHub and I'm going to authorize my application. The application authorization will call my callback route, so root/callback with the code. And when I receive the code, then I'm going to get my get OAuth result with that particular code, which tries to fetch a token from GitHub. I'm actually going to rename that method. So let's call this fetch token. And after fetch token, I'm going to check whether there is a token, so whether GitHub can give me back an authorization token. If I can supply a token, then I'm going to query GitHub again using that authorization token to fetch the user's email, and then I'm going to display that thing into the front end. If I don't get a token, I'm going to display authentication failed in the front end. That's the general idea. So let me go run my auth demo once more. This will take a little bit of time because I wrote quite a bunch of code. Hopefully this thing at least compiles. Okay, so the server seems to be up and running. Rock the JVM. And now I can navigate back to my puny little application at localhost 8080/home. So this is my little HTML. To click here to log in with GitHub, I'm going to click. And at this point, I'm going to be redirected back to GitHub's authorization flow. And once I click this green button, I will be redirected back to my second route, which is the callback thing, with a code. So I'm going to click the green button, and then I'm going to be redirected back to my authorization code. So I'm going to copy this link so that you can see how this thing looks like. So I'm redirected back to localhost/callback, which is the thing that I supplied to GitHub, along with a code. So this is a one-time code that GitHub has created for me. Now, once I access this URL, if you take a look at the route, we try to get the OAuth result, which means that we are going to fetch the token from GitHub. And if we have a token, I'm going to try to fetch the user's info. If the token doesn't exist, then I'm going to get an authentication failed, which is not the case here. So I get a valid JSON, which is this result of the fetch user info. Let me show you how this JSON looks like. So it's quite a long one. We have an array of users that have emails, primary, verified, and visibility. And there are a bunch of emails associated to this GitHub account. So I'm going to simulate that by a case class with the same fields. So let me go at the bottom of the app, and I'm going to create a case class GitHub user with email as a string, primary as a Boolean, and verified as a Boolean. So this shows you whether the OAuth provider has verified your email address. And I also need a JSON decoder, but because I don't have any different field names than the ones in the JSON, I don't really have to create a decoder manually like I did for the other data structures, but rather I can simply say in Scala 3 derives decoder. So an implicit or a given decoder of this type will be automatically provided in scope because the email, primary, and verified are the same names in the case class as they are in the JSON. So email, primary, and verified, the visibility can be ignored. Okay, so I'm going to parse that particular result, which is this fetch user info. So fetch user info shoots the request and gives me back that JSON string. So I'm going to map that, the map that I had removed 5 minutes earlier. So I'm going to say decode of type list GitHub user, GitHub user. On that response, so response, arrow, decode list GitHub user on that response. This is going to be an either, so I'm going to convert that to an option. Then I'm going to flat map that. And I'm going to try to fetch the first user that is primary. So I'm going to say underscore find underscore primary. Okay. So I'm going to decode, this returns an either, then I'm going to turn that into an option, then I'm going to flat map that, and because I have a list of GitHub user, I'm going to try to find the first thing that is a primary, and there is only one such thing in the list. Okay. This is going to return an option string, so I'm going to match case some user, and I'm going to return a success. So I'm going to say success logged in as user email. And in case we get a none, I'm going to return no primary email on GitHub. And that would be weird. And I'm going to have my variables nice and tied up. And I'm going to save, and I'm going to restart my server. And I'm going to follow the same flow so that we don't see that weird JSON on the front end, but we're going to see a nice little welcome message, success logged in as my little email on GitHub. All right, so we have Rock the JVM. I can navigate back to localhost 8080/home. Let me increase the page size. So click here to log in with GitHub. Now, the next time where you click on this link, the authorization flow will not be triggered anymore because you've already authorized the application. So once you click this thing, it will simply return the appropriate response. So it will take a couple of seconds to get my server in contact with GitHub, and we have a success logged in as my primary email on GitHub. And we have a success. So this was a long-form tutorial on how to do open authorization with Scala and Http4s with GitHub as an authorization provider, which you can replace with Google, Microsoft, or any other third-party application. I hope this tutorial was useful and valuable for you. If you did find it valuable, go ahead and click the like button for me and subscribe to the Rock the JVM channel. For more videos like this, check out my blog and my website at rockthejvm.com. I have literally hundreds of hours on everything on Scala and Kotlin and everything in between. Until next time, folks, this is Daniel signing off.